So I need to make sure that we are being recorded. So what is linear programming? I will explain with the help of illustration 1. And in this illustration, department A has only 11,000 hours, not more than that. So we have limited time in department A. So there is one limited resource. In department A, there is a limited resource. In department B, on the other hand, also you see there is a maximum of only 9,000 hours, not more than that. There is a limited resource. And so on, there are other limited resources also. Okay, now what we need to understand is that in simple terms, whenever there are more than one limited resource, we need to ensure that we are making best use of our limited resources. You understand? That is what we're going to look at. We make best use of limited resources and identify how much to produce in those limited resources. And what we do is this. I will put it in very simple terms. Instead of saying, oh, number of see, we have two products, correct? X's and Y's. I want to know with the limited resources I have, with the limited resources I have, how many X and how many Y I can produce. Okay, but instead of saying number of X's produced, number of Y's produced, the first step is to simplify our life. Don't waste your energy, don't waste your time. Instead of saying number of X's produced, from now on in this question, until we do this question, we will call it X. Instead of saying number of Y's produced, I'll just call it Y. Instead of saying total contribution, I'll just call it C. So I'm making my life easy for you. I'm making your life easy. So the first step is to give nicknames to all the variables. Define the variables. Now, I don't want to use complex terms like that, define the variables and all that. What we're doing is simplifying the names. That is the first step. So first step is what? First step in this is to simplify the terms by giving them names, all right, which is basically defining the variables. So from now on, number of X's produced will be denoted by X. Number of Y's produced will be denoted by Y. Total contribution will be denoted by C. So from now on, whenever I say C, it means total contribution. What is the second step? See, again, we're trying to make your life easy. Just look at department A. Each unit in department A, to make 1x, just follow my cursor and look at what I'm highlighting. To make 1x, it will take 8 hours. And what did I say X is? X is the number of X's produced. So 8 hours for 1x, that needs to be multiplied with the number of X's that I will make to get the total number of hours. So 8x plus 10y will be the total time that I will spend. Each X takes 8 hours, each Y takes 10 hours. So if we multiply, that will be the total time taken. But that time should not be more than 11,000 hours because that is a limitation, that is a constraint. 8x plus 10y cannot be more than 11,000. For each x, you need 8 hours. So number of x's into 8 will be time taken for x. Number of y's into 10 will be time taken for y. But it should not be more than 11,000 hours. So this constraint, I have simplified that in the form of a formula. So the second step is to put the constraints in formula. So what are the constraints in formula? I'm putting it here. In department A, 8x plus 10y is equal to 11,000. Department B, 4x plus 10y is equal to 9,000. Department C, is 12x plus 6y is equal to 12,000. These are all the constraints. There is one more constraint, and the constraint is there is unlimited demand for x, but the demand for y is limited to 600. Meaning y cannot be more than 600. But anyway, I'm not putting that. And also there is one more constraint. X is what? Number of x's. Y is what? Number of y's. Correct? Can you make minus 1x, minus 2y, minus 4z? Is it possible? Can you study for minus 1 hour? Can you make minus 2 cups of tea? No. So the number of x and the number of y cannot be less than 0. It has to be equal to or more than 0. It should be equal to or more than 0. Number of x, either it has to be 0 or it has to be more than 0. It cannot be less than 0. You cannot make minus 1 x's. Number of y has to be 0 or more than 0. It cannot be negative 4. This is a constraint which says that the number of x and number of y cannot be negative, and for that reason this is called the non-negativity constraint. Meaning the number of x's and the number of y's cannot be less than 0. It cannot be a negative number. So I've put my constraints in the formula. Third is I will put my objective in a formula. How do I put my objective in a formula? See, each x gives me $12 contribution. My third step is to put my objective in the formula. 12 is the contribution for each x. I don't know how many x's I'm making, but x is denoted by the number of x's. Or rather, number of x's is denoted by the letter x. 12x, I'm so sorry. Each x gets us a contribution of $4. I don't know how many x's I'm making, but the number of x's is denoted by the letter x. Plus, each y will get me a contribution of $8. Again, I don't know how many y's I'm making, but the number of y's are denoted by the letter y. 4x plus 8y is equal to C, which is the total contribution. I mentioned that when I was simplifying the terms by giving names. I'm putting that here again. Step number 1 was simplify terms by giving names, meaning x, number of x's is denoted by x. Number of y's is denoted by y. Number of contribution, total contribution is denoted by C. Now that you've done all these 3 steps, what is the 4th step that you have to do? Formulate the constraints, you've done that. 4th step is draw a graph identifying the feasible region. Now this is where things get interesting. Draw a graph. I will draw the graph, but finally I will show you the textbook graph for the sake of neatness, because here I'll not be able to draw the graph neatly. How do I draw the graph? Is I have to plot my constraints on the graph. Again, I'm going to close the textbook now. This is step 1. This is step 2. This is step 3. Now I have to plot my constraints on a graph. How will I plot my constraints on a graph? Go back to the constraints. What is the constraints formula? The constraints formula is over here. Look at the first constraint, department A. Let's work on that. I'm turning the color into black. 8x plus 10y is equal to 11,000. Let's just assume it's an assumption. Assume x is equal to 0. If x is equal to 0, y is equal to how much? Think about it. It's simple math. If x is equal to 0, x 0 into 8 will be 0. So 0 into 8 is 0. So this will go away. If x is equal to 0, it will become 0 plus 10y is equal to 11,000. Therefore, y is equal to 11,000 divided by 10, which is 1,100. So if x is equal to 0, y is equal to 1,100. On the other hand, let's assume. In this case, we will assume that each of them are 0. And what will be the other one then? If y is equal to 0, x will be equal to, think about it, if y is equal to 0, 0 into 10 will be 0. So the formula will be 8x is equal to 11,000. 8x is equal to 11,000. So x is equal to 11,000 divided by 8 because 8 goes to the RHS. So 11,000 divided by 8 will be 1,375. So what is happening? If y is equal to 0, x is equal to 1,375. So what I'm going to do is this. This I am going to plot on the graph. I want an empty sheet of paper. This I'm plotting on the graph. Okay, and this is my graph over here. This is the x-axis, so let this be the number of x's. This is the y-axis, so let this be the number of y's. Let me see if that is the same in the textbook also, so that it will be easier. Yeah, it is the same. All right. Now, assume this. Again, this is what, 1,000, 2,000. So let me put it this way. Let this be point. Let this point be 1,000. Okay. So if this point is 1,000, the double of that will be 2,000. And between that exactly will be 1,500. I'm just roughly doing it. I'm not obviously doing it very. So this will be 0. And if this is 0 and this is 1,000, the midpoint of that will be 500. I'm just roughly plotting things on the graph. Similarly, if here we have 2,000, the midpoint of 2,000 and 0 will be 1,000. It's not exactly in center. This would be the midpoint maybe, which is 1,000. So the midpoint of 1,000 and 2,000 would be over here, 1,500. And the midpoint of 0 and 1,000 would be 500, which would come here. Now, what I'm doing is this, just look at my drawing. This I'm going to put in this graph. If x is equal to 0, y is equal to 1,100. Where is y? Y is equal to 1,100. So look at the y axis. Where will 1,100 be? If 1,000, just follow my cursor. If 1,000 is here, 1,100 will be somewhere over here. And if y is equal to 0, x is equal to 1,375. So if 1,500 is here, 1,375 will be somewhere over here. Somewhere over here. So now you have 2 points. Just join those 2 points and form a line. Similarly, you have to do with all the other constraints. Look at department B. Now again, I'm going to go faster. Let's assume x is equal to 0. Y will be equal to, now again, I'm doing the calculation fast. Y will be equal to 10,000 divided 9,000 divided by 10, which is 900. Let's assume y is equal to 0. If y is equal to 0, x is equal to 9,000 divided by 4. How much is 9,000 divided by 4? 2,250. So if y is equal to 0, x is equal to 2,250. So again, we will do the same thing. These points, we will plot it on the graph. But in this case, I'm putting it in a different color so that you are able to see. Okay. Red line is the department A line. So I'm putting department A in red color so that you are able to later see it. Department B will be in green color. Okay, so I'm drawing the graph. Guys, this is for you. I'm doing all these drawings, color. I feel like an art teacher. But if you're able to understand, nothing like it. Think about it. If 1000 is over here, 900 will be somewhere over here on the y-axis. And look at x. X is 2,250. Just follow my cursor, 2,250. And if 2000 is over here, 2,250 will be somewhere over here. So what will I do? 2,250 may be somewhere over here. So join those two lines. So join those 2 points. This is department B line. Similarly, we will draw a line for department C. Let the department C line be in some other color, maybe in black. Again, I'm going to move fast. If x is equal to 0, y, I'm just moving it. If x is equal to 0, y is equal to 12,000 divided by 6, which is how much? 12,000 divided by 6, 2,000. And if y is equal to 0, x is equal to 12,000 divided by 12, which is 1,000. So plot this black thing on the graph. Again, this thing, I need to plot it on this graph. So y is equal to 2,000. So y is where? 2,000 will be here. And x is 1,000, which is here. So join those 2 points. You will get the department. It's not a very straight line. So I'll just try. Stir. This is department C line. And there is also a non-negativity constraint, which I don't want to talk about because, I mean, it's just, it means that x and y cannot be less than 0. Right? But then there was one more thing which I saw in the question, and the question said that x cannot be more than 600 or something like that was there. No, I'm just going down to see where that question was. The question was demand for y is limited to 600. Okay, meaning y, number of y's cannot ever cross 600 because demand is only 600. So I'm drawing one more line, which I will put in pink color. Y's demand cannot be more than 600. So 600 will be somewhere over here. So it can never be, y can never be more than 600. So it's just, you can never cross this pink line. It can never go above this because the demand for y is only 600, not more than that. Now that I have this graph, guys, again, I could have directly showed you the graph, but the reason I drew it is so you know exactly where is the graph coming from. Everybody comfortable with how I got this graph? And all the 3 steps, 4 steps rather. Simplify the terms, put the constraints in the formula, put the objectives in the formula, draw a graph. Everybody got this? This much everybody got? Is it very easy? Quickly, everyone, fast, please. Everyone, fast. Hasham, you didn't say anything. Yes, okay. Now, what I want to tell you is these are all the constraints or all your limits. It's like these are the walls that you cannot cross because these are your constraints. Constraints means these are your boundaries. So I don't know. That is the question. I want to know how many X's and Y's I can produce. This is the question. But now I know that my answer, it cannot cross any of the lines. It cannot cross this line because that is one constraint. It cannot cross this line because that is another constraint. So the question is this. Look at brown, the brown color. Can my answer be over here? Can it be, okay, I'll make 1500 X's and 1500 Y's? No, because it's crossing both my constraints, all my constraints. Can my answer be over here? Look at the second X. Can the answer be over there? I want somebody else to say. Not Kshitij. No, because it's crossing my constraints. So my answer has to be within the boundaries that I have set. Kshitij, sorry for what? Your answer cannot also be here because see, I have crossed the red line. Your answer cannot be here because see, I've crossed the black line. Your answer cannot be here because see, I've crossed the pink line. You cannot cross any of the lines. Is everybody clear with this? You are not allowed to cross any of the lines. Chris, Eunice, Abhi, Prince Soyal, Namir, Hasham, everybody clear? Subanjo? Yes. Therefore, what happens is your answer will be in this area only. Within all the lines. It has to be only in this region. It cannot cross any of the lines. This region where you can possibly find your answer is known as the feasible region. Your answer will only be in the feasible region. It cannot cross the feasible region. So now it's like playing a game of hot and cold. Like when I was younger, we used to play a game of hot and cold, where one team will hide something. It can be a piece of cloth or something they will hide. And the closer you are, you have to search for the item. They will hide it in a room and you have to go and search for it. If you are far away, they will say you are cold. But if you are near, they will say you are hot. So it's like you're playing a game of hot and cold. It's like this is your hot region. Your answer will be in this region. So you have to find your answer only in this region. Draw a graph and identify the feasible region using the graph and constraints. Once you've identified the feasible region, I'm going to just remove this. What I will do is I will use a pseudo contribution line. What do I mean by pseudo contribution line? Go back to my notes. Contribution. What was the contribution formula? The contribution formula was 4x plus 8y is equal to c. I don't know what my contribution is. I don't know. Oops, sorry, by mistake, I removed that. I don't know, but let me assume a contribution. Let me assume a contribution of say 200. I'm taking something which is a multiple of 4 and 2 for easy calculation. I'm assuming a contribution of 200. So let's solve this equation using an assumed contribution. Why? Because I want a contribution line. Okay, so 4x plus 8y is equal to 200. Therefore, if x is equal to 0, y is equal to how much? 200 divided by 8 is how much? Pink is the constraint line. Yes, Hasham. It is the constraint line for the demand constraint. It said that y can never be more than 600. That's why I said, see y line, y can never be more than 600. Hasham, clear? So if x is equal to 0, y is equal to 200. And on the other hand, if y is equal to 0, x is equal to 200 divided by 4. If y is equal to 0, x is equal to how much? 200 divided by 4 is how much? 50. These 2 points you will plot on the graph now. Right? So think about it. This is the x line. If 500 is here, 250 will be somewhere over here. 125 will be somewhere over here. Maybe I'll take a bigger number so that maybe I'll get a bigger answer. I'm just, because again, it's an assumption. So I'm just going to take a bigger number. 4x is equal to 400. So if x is equal to 0, y is equal to 400 divided by 8. How much is 400 divided by 8? 50, correct? And if y is equal to 0, x is equal to 400 divided by 4 is 100. This is better, I feel. In fact, let me change that further. Let me change that to, let's assume the contribution is 800. So 4x plus 8y is equal to 800. If x is equal to 0, y is equal to 800 divided by 800. And if y is equal to 0, x is equal to 800 divided by 4, 200. This is better. And I purposely did it 3 times so that you realize that this is only an assumption. And I will put this on the graph. In which color? I don't know. All the colors are over. Maybe in purple. Y is equal to 100. If 250 is over here, 125 will be here. So 100 will be somewhere over here. And x is equal to, if 250 is over here, 200 will be somewhere over here. So you join both the lines. This will be the line. Now this is your contribution line, which is not the exact real contribution line. It is an assumption, which is why it is known as the ISO contribution line. Now what we will do is, the next step is to use the ISO contribution line in order to find the farthest away point. See guys, ultimately when you want to do business, you want to make as many X's and as many Y's. So obviously you want to go away from the origin point. You want to go away because you want to make more X's and more Y's. If in the ideal world, you want to go here. You want to make more X's, more Y's. In the ideal world, you want to go here. More X's, more Y's. You want to make as many X's, as many Y's. So you want to go far. But you have constraints. So what you are seeing is, using this line, what is the farthest point you can go without crossing any of the constraints? What is the farthest point you can go within the feasible region? So see guys, this contribution was a fake contribution. But the line will be the correct angle. Even if the contribution is fake, the angle will be correct. So I'm just drawing the same angle and I'm drawing more lines in the same angle and I'm seeing which point is the point. Where can I go? What is the farthest away from the point, from the origin, without crossing the... See, I've already touched this point. This point already touched. I want to know which is the farthest away. See, I've already touched this point. I believe this point where the red and the black lines meet is the point which is the farthest away point within the feasible region. Therefore, we will produce those many x's and those many y's. At this point, this is the point where we get our answer, because that is the point which is the farthest away point within the feasible region using the contribution line. So at that point, you have the highest contribution. So we have to know and investigate this further. Okay, now I will show you the, my drawing is enough now. Now I will show you the textbook drawing. I'm going to clear my drawing. Okay, maybe not clear my drawing. Because as you see, red and black line are meeting. Red and black line are meeting. Red and black line were which department? Red was department A, black was department C. Okay, now I can clear my drawing. You see, in this line, again, this was the ISO contribution line. So I have to see which is the farthest away point where I can go without crossing the feasible region. You see, I've crossed point D also. I've touched point D. So the point where the last point is point C here, which is department A line. And which line is touching? Department A line is touching and Y line is touching. So basically, again, there would have been a little bit of a, in my drawing, there could have been an issue, but that's why I'm showing you the textbook. The point which is the farthest away within the feasible region is the is the C point, where department A and the Y constraint meet. So point C is the point where I have my highest contribution. Therefore, the answer is highest contribution is in point C. Where which two lines meet? Department A line meets and the Y demand constraint line meets. That is, it says that Y cannot cross 600. Therefore, I will put that in a formula. Department A line, what was the formula? The formula was, again, go back to the question. The formula was 8x plus 10y is equal to 11,000. Anyway, I don't want to proceed further. I just want all of you to be clear. Step 1, simplify the constraints, give the names. Step 2, put the constraints in the formula. Step 3, put the objective in the formula. Step 4, draw the graph and identify the feasible region using the constraints. Step 5 is identify the point where you get highest contribution within the feasible region using the ISO contribution line. Guys, all these 5 steps, are they clear to everyone? Please let me know. Yes or no, you have to tell me, that's all. All these 5 points, are they very clear? Please let me know, guys. Prince, Abhi, Amira, Ganpat, Chris, Enis, Asham, Natasha, Subanjo. Very good. Now that you have this point, you've identified the point where you get the highest contribution within the feasible region using the ISO contribution line. You have to take the formula. I'm adding more points. Okay, I'm adding more steps because I want to break the steps of the textbook further into smaller steps. Use the 2 formulas where the 2 lines meet. See, there will be one point where 2 lines intersect, correct? In this case, it is point C. And in point C, The two lines intersecting are department A and the Y constraint. Use the two formulas where the two lines meet. So here in this case, department A is 8x plus 10y is equal to 11,000. And the other line was the Y line, which says that Y has to be equal to or less than
It's 7 o'clock.
600. So Y is equal to 600. So I'm not mistaken, that was the constraint. This question, Y cannot be more than 600. Now, all you have to do is simplify this. How will you simplify this? Simple maths. What do I mean by simple maths? It's just basic math. How do you simplify this equations, guys? Who can tell me? See, I will explain to you the substitute Y. Yes, absolutely right. See, we already know Y is equal to 600. So what I will do is 8x plus 10y. Y is how much? 600 is equal to 11,000. For now, you simplify further. 8x is equal to 10 into 6,000 is 10 into 600 is 6,000, which is equal to 11,000. Therefore, 8x is equal to 11,000. 6,000, if you send to the RHS, it becomes 11,000 minus 6,000. So 8x is equal to 5,000. Therefore, x is equal to 5,000 divided by 8, which is 625. Therefore, you have your answer. You have to make 600 Ys and 625 X's. That's it. That is your optimum production plan. Using all these constraints, I will make 600 Ys and 625 X's. You understand? That is the answer. Therefore, the final step is, once you get the optimum production plan, in my case, how many X's? How many X's I'm making? 625. How many Ys? 600. This is the best plan. Based on my limited resources, I should make 625 X's and 600 Ys. Once you get the optimum production plan, okay, let me put that this way. Obtain the optimum production plan. Once you get that, using the optimum production plan, find what is the max contribution that can be earned for the optimum production plan. What do I mean by that? Go back to the contribution formula. Contribution was 4 for each X. How many X's am I making? 625. So 4 into 625 plus what is the contribution for Y? Each Y has a contribution of 8. 8 into how many X's am I, how many Y's am I making? 600. So 8 into 600. Therefore, what is the total contribution? 4 into 625 is how much? 2,500. And 8 into 600 is 4,800. Therefore, the max contribution is 4,800 plus 2,500, which is 7,300. This is the maximum contribution you can make. Try any other mix. I challenge you. You will not be able to get more than this contribution within the feasible region. This is 625 X's and 600 Y. This is the maximum. This is the best. I hope everyone is clear. And I hope nobody has a problem. And that, guys, with that, the entire linear programming is done. Now, again, if you have issues with Slack, if you have issues with shadow price, that is a different thing, which altogether is, I will say, it's something that's very simple. It takes about another 15 minutes to do Slack and shadow price, but this is linear programming. If you've understood each of these 8 steps, first step, simplify the terms, give them names. Instead of saying number of x's, say x. Instead of saying number of y's, say y. Instead of saying total contribution, say C. Put the constraints on the formula. I put all my constraints in the formula. See this? Department A, Department B, Department C. I put all of them in the formula. I also put my objective in the formula. My objective is the contribution 4x plus 8y is equal to C. Then I used the formulas and drew a graph using the formula where I am assuming what happens if x is equal to 0, I get the value for y. What happens if y is equal to 0, I get the value of x. So using x and y, I draw the line for department A. Similarly, I make assumptions and I draw lines for department Y. I draw lines for department C. Sorry, I draw a line for department B. I draw a line for department C. I also draw a line for the other constraint, which is y cannot be more than 600. So all the constraints, their equations, I'm putting in the lines on a graph, which is step 4. Using that, within all the lines, the region within all the lines is the feasible region. My answer has to be in that region. I'm not allowed to cross that region. 5th step, you create an ISO contribution line, which is a fake line using a fake contribution, fake total contribution. Actual total contribution is 7,300, but I used a fake total contribution of 800. Why? To get a line, ISO contribution line, not the contribution line. It's the ISO, pseudo, pretend, imaginary contribution line, just to get the line of slope of the line. Once I get the slope of the line, using that same slope, whether the slope is like this or whether it's like this, using the same slope, I have to move as far out of origin as possible without crossing the feasible region. That point within the feasible region, where the last point will be the point where you get the highest contribution. At that point, see which 2 lines meet. Use the 2 formulas for those 2 lines and obtain the optimum production plan. Using the optimum production plan, you can find out what is the maximum contribution. 8 simple points. Now, guys, tell me, what is your rating? What is your understanding? What is your confidence for linear programming on a scale of 1 to 5? 5 means you've understood it comfortably. You are happy with linear programming. 0 means it felt like I was teaching in Japanese. Because last time only Kshitij said 5. So I want to know now how many are at what. Chris, Yusuf, Subanjo, Hasham are 5. Eunice is 5. Amira, what about you? Subhanjo, you want me to do Slack and shadow price. Okay. HP, Namir, Natasha. Yes. Perfect. So this is how I teach, guys. I mean, I don't normally look at the textbook much. I just refer the textbook and give you my points, tips, tricks, which simplify things, hopefully, for you. Now, Sobanjo wants Slack and shadow price. What is Slack? What is shadow price? I will do it in the next 5 minutes. Okay. See, when I said that in department A, I have 11,000 hours, I said that I have maximum 11,000 hours. I didn't say that I have to use all 11,000 hours. For example, when I was teaching audit and assurance, maximum time I was allotted was 60 hours. I cannot cross 60 hours, but I can complete it in less than 60 hours. So for example, maximum time available for me for audit and assurance paper was 60 hours. But I don't have to take all 60 hours. 60 hours is the maximum time I have. I completed audit and assurance. Time audit and assurance was completed in. I completed it in 55 hours. So I have unused hours. How much unused time do I have? How many hours unused time do I have? How much? 5. How many hours? I had 60 hours, but I completed in 55 hours. So my constraint was 60 hours, but I took only 55 hours. So my unused time is 5 hours. This unused capacity, this spare capacity, this unused limited resource is known as slack. For example, look at Department A. According to Department A's equation, what was Department A's equation? 8x plus 10y is equal to 11,000. It cannot cross 11,000. X is how much? As per what we got, X is 625. Y was how much? Y was 600. So 8 into 625 is how much? I'm getting 5,000. And 10 into 600 is 6,000. So how much time did I use? I used 11,000 hours. So see, time available was 11,000 hours. Time used was 11,000 hours, meaning there is no unused or spare capacity, meaning there is no slack. So in this case, slack is 0. Moving ahead further, what about Department C? 12x plus 6y is equal to 12,000. 12x plus 6y is equal to 12,000. So x is equal to 625. I already know that. Y is equal to 600. I already know that. So 12 into 625 is how much? 7,500. And 6 into 600 is 3,600, if I'm not wrong. So 7,600 plus 3,600 is 11,200. I'm getting 11,200. So Banjo. So you see, in Department C line, time available was 12,000. Time used was 11,200, meaning there was slack or there was unused limited resource. There was spared limited resource. There was slack of how much? There was slack of 800. So I hope Sobanjo slack is clear to you. All right. And believe it or not, take it from me as a challenge. Let me look at the graph. Believe it or not, take it from me as a challenge. Even without doing the calculation, see, I calculated, right? Department A, there is no slack. No slack in Department A. Department C, there is a slack of 800. Believe it or not, I'm challenging you. Department B also has a slack. Can you check what is the slack of Department B? All of you? How much is the slack? I'm challenging you. There will be a slack for department B. This is a challenge. How much is the slack? How did I know there is a slack? Can anybody guess? How did I know there is a How did I know there is a slack? Who can tell me this? You are all claiming that you have completed PM. I want to know, before you told me there is a slack, I told you there is a slack. How? I told you there is a slack for department C, and you are telling me now that there is a slack of 500. How did I get the answer? Who can tell me? How? Maybe using the graph, Hasham. How can I say using the graph? You are right, but how? Because this is unfortunate, nobody knows. Again, you all feel that you're done, but you have to work very hard in the next 12 days. See, my answer was at point C, meaning I'm on the department A line. I have reached the line, meaning in department A, I have reached the line. I have reached the limit. There is no slack. Similarly, there was one more constraint which said that y cannot be more than 600, and I am on that line, meaning there is no slack, meaning I have made all 600 y's. But my answer is below the department B line. See, where is the department B line? My answer is below the department. This is the department B line. This one, it is below, meaning it is still under the line, meaning I haven't reached my limit. Meaning there is still slack. There will still be spare capacity. Similarly, my answer is at point C, which is below the department C line. Department C line is here, meaning it hasn't reached the line. It hasn't reached the limit, meaning that there is still capacity. There is still slack. So just by looking at the graph, I know that because my answer is at point C is where department A is, meaning I have already reached the department A line, meaning department A, I have reached the limit. There is no slack. Without calculation, I can tell you this. But because my answer is below department B line, it means that department B, I haven't crossed the limit. I haven't reached the line, meaning there is still spare capacity. There is still slack. Same goes with department C. My answer is below the C line. Therefore, there is still spare capacity in department C. Are you all very confident with slack now? Yes or no? Quickly type. Okay, now before I move to shadow price, I want to know how many of you feel that we can do one more marathon, or you feel that this marathon is really helping you understand core concepts. It's really, I want to know your overall feedback, your overall thoughts for this marathon. You can feel free to share. If you hesitate, I mean, there's no need to hesitate, right? Just share your feedback, just share your thoughts. If it is good, I want to know why it is good, what is helping you, what is an experience that you are liking? What is an experience that you are not liking? Also, you can tell me. So I want to hear your thoughts, your feedback, your overall experience. Just type it. And along with that, you can also type if you want another session of the marathon. Accordingly, we can arrange. Okay, guys, I'm back. So Banjo. Okay. Okay. Chris left. We have a strength of 9. Others, let me know. All okay. I mean, I don't know the silence. What does it mean? Anyway, based on the overall demand, we will decide whether we have to have another marathon or not. Yes, Yusuf? We will go with what? Important topics. That's what. Important topics, topics that you want. Linear programming is important. Okay, one more, some important topics could be relevant costing. Some topics could be, so it's overall whatever you want, everything you want, you can have. Variances, yes. So in the second session, which is tomorrow, I think we'll decide tomorrow, right? In the second session, which is tomorrow, before I start the session, I'll give you 5 minutes. You make a list, just type down all the topics you want me to cover, important topics, which you feel are hard for you. Today also, I haven't done anything based on my choice. Based on what you people told me, I've done that. Tomorrow you put it beforehand so that I will stick to that and I will just complete each of those topics and go. All right. Overall, how is it, Yusuf? And again, let me know. Maybe my team will share a feedback form with you. Fill that feedback form, and over there, if there is an option, I don't know, honestly, frankly speaking, I don't know. If there is an option asking for another marathon, you can tick that. But if there is no option, you can mention it, right? So I don't share that. My team will share it. So make sure you fill it. Make sure you share your feedback. If you like the class, make sure you put why you like the class. If you don't like the class, tell why you don't like the class. If you want another marathon, mention that. Everything, take some time and type things out. Okay. Now, one more thing, like the last thing that I will do for the day, because already I feel the strength has gone down greatly. And I don't want to start a topic like relevant costing or variances in the last 30 minutes. So the last topic that I do today is Slack is done. Shadow price. What is your doubt, Yusuf? What is shadow price? Shadow price is, see, when there is a limited resource, you still can get more of that resource. What do you have to do? You have to pay some money. For example, I am in Chennai. I'm based out of Chennai in India. Okay, again, whoever wants to stay in touch with me, WhatsApp on this number, LinkedIn connection here. I stay in Chennai. Okay. Suppose in Chennai, there is a shortage of wood. Yes, wood shortage is there. Yes, there is not so much wood. But that does not mean you can never get wood. All you have to do is pay some more money. So shadow price is what is the maximum you are ready to pay, the max amount you are ready to pay to get one. See, I put it in caps, one extra unit of the limited resource. Okay, so Banjo, I will do it for, I don't know which department, department A. Where is it? Which four? Between all four, which four? Relationship, principle, pattern. Yeah, sure. I'll do that. Just send this to me if you can. Okay. But let me just complete. Exactly the same question came. Okay, no problem. Just send it to me on WhatsApp. Okay. Shadow price is the maximum amount that you are ready to pay for one extra unit of the limited resource. For example, Slack I've already explained. Let me use the same example. First and foremost, what was the Slack? I'm directly copying it from the textbook because it's faster. I've anyway taught you how to do Slack. But for department A, where did it go? For department A, there is no Slack. For department B, there was a Slack. Also, product Y, demand, that was also a constraint. Demand is not more than 600. Again, there is no Slack. But I'll stick to the departments, okay? Department A, no Slack. Department B, there was a Slack. Department B Slack was 500 hours. And Department C, 900 hours. In Department C, 900 hours. First of all, in Department B and C, there is unused capacity. There is spare capacity. Tell me one thing, guys. If you have unused milk at home, will you go to the shop, pay more money and buy milk? No, because you have unused milk at home. Because Department B and Department C have Slack, we are not ready to pay any money to get one more unit of the limited resource because I already have unused units. So why will I buy one more unit? So Department B and C, since they have a Slack, there is no shadow price. Department B and C, shadow price is 0. Why? Because they have an unused capacity. Since they have unused capacity. But what about Department A? Department A has no Slack, meaning if I get one more unit of Department A, how much extra can I earn? If I get just one more unit of Department A, what can I earn? So what is the Department A equation? My God. Department A equation is 8x plus 10y is equal to 11,000. But I'm just pretending it is 8x plus 10y is equal to 11,000, correct? But I'm pretending, what if I get one extra unit of department A? Just one. Also, what was y? Y is equal to 600. So think about it, 8x plus 10 into 600 is equal to 11,001. Therefore, 8x plus 6,000 is equal to 11,001. Therefore, 8x is equal to 11,001 minus 6,000. How much is 11,001 minus 6,000? 5,000. X is equal to 5,001 divided by 8, which is 625.125. See, by just getting one extra unit of department A, you can make 0.125 x's more. And because of that, what happens to your contribution? What is the contribution line? Contribution line is 4x plus 8y. Last time you got 4x plus 8y. Last time you got a total contribution of 7,300. You remember, Sobanjo? Before, the total contribution was 7,300, original total contribution. You remember this? But now, because of the shadow price, because of getting one extra unit in department A, what is happening to the total contribution? It is becoming 8. X is equal to 625.125 plus 8x plus 10. What is y? Y stays the same as 600. So what happens to the total contribution? 8 into 625.125, which is 5,001 plus 6,000. So 5,001, I'm sorry, excuse me. Sorry, I put it in the wrong formula. 4x, total contribution is 4x. X is how much? Now, because I got one extra unit in department A, X is 625.125 plus what is 8y? Y is 600. So 8 into 600 is, I have to do the calculation. How much is the new contribution? 4 into 625.125 plus 4,800. I'm getting 7,300. The new total contribution by getting one extra unit in department A is 7,300.5. So you're getting how much extra? How much extra are you earning, guys? I think I have to stop. The responsiveness has gone down. I think our attention span has gone. How much, guys, please? How much extra can I get? Am I getting? 0.5. Therefore, the maximum amount that you are ready to pay to get one extra dollar in department A is only 0.5 because the benefit is 0.5. Therefore, the shadow price for department A is 0.5. Okay, so shadow price is done. So these are the 15 topics we covered today. Tomorrow, beforehand, you let me know which topics you want me to do. Quickly tell me now if you have to rate your confidence, your satisfaction for these 15 topics. Again, these 15 topics were chosen based on your demand. So if you have to rate your confidence, your understanding, your happiness, your satisfaction for these 15 topics, how much will it be? 5 means you've understood perfectly, 0 means you didn't understand anything. 3 means something you understood, something you didn't understand. Quickly type reference. Are you understanding the question?